Very glad to see you all in this room. As some of you might know, this is my last SEMIC, at least as an organizer. And therefore, of course, I'm absolutely thrilled to have here 4 key experts, some of which I have worked with intensively, other people whom I think it's the first time that Oscar and I met. And then also, Peter, you were already with us last year. And Alberto, also very glad to have you on board. So absolutely 4 brilliant experts who will, I would say, entertain you this afternoon on, I would say, the whole key topic of the conference, in the sense that we all know that, I would say, very often traditional semantics and AI, they kind of presented as a kind of a black and white situation where either you're in the camp or on the side of the traditional semantics, the thesauri builders, the people who fine-tune taxonomies by hand, and then the people who are crunching large amounts of data with machine learning. I think everyone understands here in the room that, of course, the 2 approaches should hold hands. And so I'm very happy that the 4 experts here today will both, let's say, from a practical perspective, but also from a theoretical, conceptual level, talk a little bit about how we can develop a nuanced vision on how semantics and AI can work very nicely together. So the very first speaker here today is, I think, one of the leading professors in Spain and in Europe, Oscar Corcho. I'm absolutely delighted to have him opening the event. I regret that we didn't kind of connect a little bit sooner in my SEMIC career, but I'm sure that in my future track in Agri, perhaps your research group will also be able to work a little bit on agricultural data. So Oscar, I'm absolutely delighted to have you here with us. I don't know if we can get the slides of Oscar already on the screen, and we have a microphone. So Oscar, delighted to have you with us, and thanks again.
Yeah. And you are responsible for... Oh, let me just check. Is it working? No? Yeah? No? Yep. Yeah. Okay. And you're responsible for making sure that I'm not going over time. Yeah. That's also an important thing. Okay. So, hello. I mean, I'm very happy to see many of you over here. And I mean, I really hope that my first presentation, which will be a little bit going into the technical side, I know that the rest of them are then going to be moving forward and going also into the future. I'm going to be on the present, on the present of what we are doing currently on knowledge graphs and which are the main challenges, barriers, lessons learned that we can obtain from there, So, I mean, I decided to do a very long title for the talk, which was how do we govern knowledge graph construction and maintenance? I mean, this is a knowledge graphs session. There is a little bit of AI as well, obviously. I mean, when we are creating knowledge graphs, one of our main ideas is really to produce the data in a systematic manner that can be used afterwards, for all these cool machine learning techniques, But I will be mainly concentrated on the processes, because I think that that's something where we have plenty of lessons learned, from the experiences that we have obtained, in these days. So, in general, I mean, I really like starting with the take-home message, just in case that you are already tired, I mean, and you haven't had enough coffee, and then, I mean, you have the message that I want to really provide over here. And the main message that I have over here is that slowly, I mean, as we have been progressing over generating ontologies, creating all our semantic interoperability platforms, doing all the work that we all know how to do, I mean, and then I will have a question for many of you afterwards. There are many artifacts that are being generated in the process, And unless we are actually governing them nicely, we are maintaining them nicely, we are taking care of all of them, we will have projects that will not succeed. And I'm pretty sure that we will all have experiences and we will be able to discuss on later on, I mean, in the discussion time or even after the coffee break. So, I mean, what I'm really expressing over here is that the need for really good governance principles, governance models, that really allow us to have projects that will be sustained in time, yeah, that will be successful over time. And this is the main message. Yeah? This is what I'm going to be commenting, and it will be based on some of the experiences that we have had in many different projects. I mean, I have just selected 4 over here because they are quite different, yeah? I mean, like some of them are on working with university research data, with databases, Oracle databases, I mean, like reusing the Oracle facilities for generating knowledge graphs, yeah, which is quite nice, yeah? But it has also some challenges, and with databases of more than, I mean, almost 2,000 tables, yeah? So you all know, some of you probably have gone through these cases. Also, other ones where we are doing the full life cycle from generating the ontology network to generating knowledge graphs that we cannot even see, yeah, because they are industrial. And I mean, I have no access to those knowledge graphs. I have no idea of how they look like now, yeah, okay? But I mean, again, I mean, there are plenty of lessons learned from that. But especially, I mean, I will be concentrating on one of the cases. I mean, I will be commenting a little bit more, and I see representatives from the European Agency for Railways over here. Marina, nice to see you over here, where we have been going through the whole life cycle. And I mean, we already inherited the project that was already started by the really good people of Ghent, yeah, who were working on that. And there are plenty of lessons learned that we are obtaining from that process. Yeah? Okay, so that said, the main question for you is how many of you have been involved in generating knowledge graphs? Hands up, yeah? I mean, no green or red cards, yeah? Many of you, yeah? Okay, and I mean, for those of you who have been involved on this, how many artifacts do you use in the process? 1, 2, 3? Plenty of them, yeah? These are many of the ingredients, yeah, that we are using in all these projects, yeah? I mean, obviously we have ontologies, yeah? We have been talking about this quite a long time, for a long time. We have also lots of control lists of terms, authority tables, thesauri, and so on. We have ideally declarative mappings, yeah, that allow us to be a little bit more sustainable over time on the changes that we are doing, but we also have to develop ad hoc scripts, yeah, for transforming data. We have SACL shapes, yeah, now they are very cool, yeah, just to detect and to validate the knowledge graphs that we are generating, and we are also generating ways to exploit the knowledge graphs. So all these elements are part of the menu, yeah, of the ingredients that we have to use in this type of projects. And we have to be very careful about maintaining all of them because there are strong interdependencies, relationships between all of them, yeah? And that's when it becomes a little bit tricky, yeah? Okay? So we know, I mean, that our ontologies and the authority tables, the thesauri, they provide the homogenization layer, yeah, that we really need when we are overcoming the heterogeneity of many data sources. We have all these non-ontological data sources that are in heterogeneous formats as well. I mean, like in the case of ERA, we have to use XML, yeah? Which is a little bit ugly, yeah? But I mean, this is what it is, yeah? And in many cases, we would love having databases, but I mean, we have to move into XML, and that brings interesting challenges as well. And in the end, I mean, we have this RDF data, which is annotated according to those ontologies, yeah? You all know this, yeah? I mean, like those ones who have been involved in this type of projects, yeah? So, just to set up the scene of the use case, I mean, like the one that I can comment a little bit more on. I mean, you will see that there are only a couple of references, but then I'm really happy, together with Marina, probably, I mean, to explain many of the things that are happening, going on. This is one of these cases where we have all these ingredients together, yeah, all of them. So we have the ontology development, I mean, like a version ontology with all the changes that are coming in, and also, I mean, ontology that in the future will be useful to generate elements that are related to the regulation, yeah, okay, the corresponding regulation. We have plenty of concept schemes, yeah, that have been necessary in order to overcome data that is coming from different data sources, and that has been a challenge, yeah, because we have had to do lots of manual processes. Many of you know about this as well. And we have all these SACL shapes and so on. So the main idea is that we are building, yeah, over here a knowledge graph that is coming from many different member states, is coming from some data sources that were already a little bit homogeneous, yeah, because there was some XML formats been involved over there. Probably there is some automatic thing over there. And then, I mean, like we are also generating lots of reference data over there, yeah? There are some highlights, yeah? Is this an easy project? Well, I mean, like the effort that has been required for the ontology development and knowledge graph creation, I put over there 20 person months, probably is going a little bit more. I mean, and it will continue because there will be more elements that will need to be added. In the end, I mean, it's probably not too much data, 8 gigabytes of RDF enquads. Okay, well, I mean, for those ones who are interested on the size. But especially, I mean, I would really like to stress the fact that we need several validation layers at the XML part and on the RDF part. We have a large set of scores values that have had to be refined. So all this is something that is time consuming. And I mean, it would be a pity to do such a project, to work on this, generate such a knowledge graph, and then not reuse it, not maintain it over time. I mean, I think that that's the main idea that we have here. Yeah. Mm-hmm. Okay. So just a snapshot of the part of the ontology. Okay, I mean, talking about tunnels, tracks, sections of lines, the operational points, things that are very typical from here. No need to go into details on this, of course. Also, lots of boxes on what is the process that we are doing for the generation of the knowledge graph. It's not just a simple box. I mean, it's not just a black box where we have all the process done, but there is a lot of verification that has to be done at the XML level. We have the knowledge graph generation with the tools that can exploit declarative mappings. We have verification and validation using SACL, and in all cases we have to go back into the original data sources to say, okay, this is the problem. I mean, this is something that we are fighting with, yeah? Okay? And in all of these cases, there are new artifacts that are appearing here and there, yeah? That's the main challenge that we are having in this type of project. So, yeah, we have the ingredients. How do we cook them? Yeah, how do we generate a nice dish? Yeah, out of these ingredients. Well, there are methodologies, there are methods that have been proposed for knowledge graph generation. Yeah, I mean in the context, I mean, like probably many of you know them. Yeah, I mean, like I have even gone to some of the old ones. Yeah, that were proposed when talking about government linked data. Okay, and they are in W3C nodes and things alike. And they are all talking about more or less the same steps, sets of steps. One of the problems that we have is that whenever we were thinking about ontology engineering, we had a very clear set of steps that we had to follow. Yeah? But suddenly, I mean, like we finished whenever we were producing the OWL file. And that was all, yeah? I mean, me as an ontology engineer, I was very happy. I produced my OWL file and then that's all, yeah? However, new artifacts are appearing, yeah? These SACL shapes, yeah? That are being generated from the ontology. The initial mappings that we generate automatically from the ontology as well, yeah? The APIs, yeah? That we are also creating in order to exploit the data that we have in the knowledge graph. The Sparkle queries that are related to the competency questions. All those elements have to be maintained, properly maintained and properly governed, yeah? This is the main message again, yeah? Mm-hmm. So, all these, in practical terms, I mean, most of these projects that have been focused, most of these methods that we have been working with have been focusing on the one-off creation of the knowledge graph. I'm not sure, I mean, whether you agree with me, yeah? But in many cases, probably you have been in that situation. I create the knowledge graph, I forget about it, I go to the next project, yeah? And I move on, yeah? And then, I mean, like when you dig out into everything that was being used, yeah, in that process, you realize that you are missing many of the ingredients, the elements that you were using in that process. Yeah. Okay. And there is very little that I have seen on knowledge graph maintenance. Yeah. On what is the actual maintenance of something that is living and where there are lots of applications that are being based on this. Yeah. Later on, we will have in the presentation from Ralph. He will be also commenting on additional elements, yeah, that we have also to consider, or in the future we will be considering, like, for instance, the models, yeah, that are using all this data. So this shows that continuously, I mean, in the following projects, we will have also these kind of things, and there will be new artifacts that we will have to take care of, yeah. So, in terms of going into a little bit of conclusions and recommendations, and I have a longer presentation for those ones who are interested, I mean, and that I can share with the recommendations, I mean, one by one, going through them. First of all, I mean, my first question would be, is it possible to propose a more comprehensive method or methodology for this knowledge graph creation and maintenance? I mean, It's probably too early to explain. I have some people working on it, and I mean, we will try to get, I mean, all these lessons learned and put them together so that we can have something that we can offer, yeah? I mean, like, I'm pretty sure that you could all contribute to this, yeah? Okay? Second thing is there at least a menu of recommendations that we can follow? I mean, so as to be successful, yeah? And this is the recommendations that I will provide. And finally, okay, well, let's see these recommendations, yeah? Okay? So, I have just taken 4 recommendations, very simple. I mean, like, you will see that they are naive, yeah? I mean, you will say, yeah, of course. I mean, why shouldn't I keep track of all versions of these products, yeah, in a version control system? We all do, no? I mean, I assume that you all do, no? Yeah? I mean, I assume that this is mostly what you are doing, but also a good versioning system of the ontologies that we have and all the products, yeah? Because we are really struggling sometimes with all these different versions and many steps that have to be done manually, yeah? Second thing is that we need to have clear standards, principles, conventions to manage all the artifacts, yeah? There is no major research there. I mean, it's something that we all know from software development projects, but, but we should really go and, I mean, and try to make something that is replicable, that is reusable. And I mean, this was something that I was proposing yesterday in one of the workshops where we were on the need for having governance principles that can be copied and pasted, yeah, I mean, and reused. Third one, the methods and methodologies that we have for all these artifacts have to be improved, yeah? So, for instance, I mean, I have not seen much work on how to generate good SACL shapes from ontologies, from our ontologies. There are a few things, yeah? We are even having tools for generating them, but not to maintain them, okay? If I change something on the ontology at the conceptual level, how do I change it in the SACL shapes? Not to do it manually, yeah? Or at least to improve my support, yeah? And finally, we have to manage all the maintenance of all these versions, yeah? These are some very basic recommendations, and I can go in detail on how we are doing it in these different projects, for instance, in the case of ERA, but I think that, I mean, I can go now to the main take-home message again. Take into account that we have many, many different elements. We are claiming that we are doing declarative mappings, that these are more maintainable, that our knowledge graph creation projects are going to be much more maintainable, but if we don't have a good governance on them, we are not going to succeed, yeah? So that's my take-home message. I want it to be just on 15 minutes, just to make sure that we can then continue and have a good discussion, so thanks. Mm-hmm.
Thanks a lot, Oscar. I'm sure that a couple of people will have some questions. I don't know. Marina?
You know me, Oscar, I'm good in the questions, not in the best practice, but yes, in the questions. Imagine I present you my colleague here, it comes from UIC, and they have their complementary, because you know that we have model the business to governance railway ontology, and that's our aim, no? The agency as an authority hosts the ontology. We even claim that is the first legally binding ontology because we put it in the in the legal instrument. And now our colleagues from the railway industry, they want to extend for the business-to-business ontology. And is it this part of this governance? Any proposal? Any idea? That's my question.
Yeah, I think that, I mean, like yesterday in the discussion on registries, yeah, on the registries for the EU registry for semantic artifacts, we were discussing partially on that one, yeah? What are the governance principles that we should follow in order to allow these extensions to happen? I mean, and we have had lots of experiences in standardization activities, in many of the activities that have been done here and there, but we should set them up. Yeah? I mean, it's not going to be rocket science. I mean, it's going to be based on all the work that has been done in software development projects, for instance, or in standardization efforts as well. But there should be clear governance principles. I mean, like if somebody has already defined, I mean, like if for instance, the agency has already defined the concept of tunnel, it wouldn't really make sense to recreate that concept again, yeah? I mean, like, That's quite obvious. I mean, we all know that, yeah. I mean, I know that this is going to generate a lot of discussion, yeah. I mean, a lot of arguments. Probably, not in your case. I'm not sure, or yes, yeah.
He
But
thinks that the tunnel has 2 tubes, so it's sliced to be different.
so most probably, I mean, that's the place where there has to be a clear committee. I mean, like discussing on which are those governance principles, and I think that it's a social process. I mean, rather than a technological process only. Yep.
In this sense, I would like to add that in the case of the agency, it represents we are using the data-centric and the technology to align concepts in the legislation. So it's kind of bottom-up approach to harmonize terms. So yeah.
Yeah, I think that it has an effect. I mean, and we all know as well when something is legally binding, it's also something that will have an effect. So my main idea is many of these technical documents, norms and things alike, should actually have a link where you actually go to the definition of that is available in ontology. I mean, but that's quite clear, yeah? Yeah. Yeah.
Claudio?
So, Oscar, yes, it's difficult to argue with any of the points you made because they're really common sense. If you've been long enough and around this field, you know that at some point the weakness is, in fact, the long-term value, guaranteeing and maintaining long-term value of a knowledge graph. So for me, it's not much of a question, but like give us maybe like a hint of hope. How early do you see this happening? Like that people becomes really sensitive to this topic, and they want to become active in this.
Mm-hmm. So I think, I mean, in this case, I mean, this very specific case, just to I mean, like center it around or focus around this specific problem that we have been dealing with. The problem that we are seeing is that there were lots of problems of heterogeneity on the original data sources and lots of missing values on the original data sources. So exposing this data, I mean, doing this process, that could be a completely different process. It could be an ETL for something else. Exposing, I mean, running this process has already exposed some of these deficiencies. Yeah, and it is useful because, I mean, then you can go back into the data providers and say, okay, well, I mean, these are the areas where you are not performing so well. These are the things that you cannot check, yeah, because, I mean, you don't have that data, that specific data. There was a very interesting case in Spain, yeah, with the trains that were bought and then they couldn't go through the tunnels. Yeah, and then we were checking, I mean, I don't know whether this is politically correct or not. We were checking the data because I said, oh, this is part of the news, yeah, that we can do. And then I realized, I mean, that we didn't have the information on the height of the tunnels from the data provider in Spain. So, I mean, how can you actually prove it? Because I was going to, I mean, go to the newspapers and send the links, yeah, just to check these things, yeah. So, I mean, at least this is a useful exercise. Homogenization is always like this, a useful exercise in order to realize about your missing information, which is already something that goes into quality of data. And this is what can sustain the efforts. Yeah? Mm-hmm.
Thank you.
I might just have a question myself on the public procurement data space, which you mentioned. So I know that also some of the colleagues of SEMIC have worked for quite a number of years on the e-procurement ontology. Yes. So could you say a little word about what exactly will be the work that your team will be performing in the context of that project, and what will be the timeline?
Yeah, so there are several teams working over there. In fact, I mean, there is a major team, which is a company that is working on that. We are mostly on the advisory part of, I mean, checking all the results that are being produced in order to ensure, I mean, that it is going in the right direction. I mean, whatever right direction means. And in fact, I think that, I mean, like a very nice thing from this public procurement data space work is that there is a lot of seminal work on that e-procurement ontology, which I really think that has been done very well, very nicely, following good steps on the process, yeah, that had to be followed in order to generate the ontology, in order to discuss on the ontology terms, the conceptualization, and so on. I think that there are next steps that also have to be done in order to generate all the artifacts that will be needed, yeah, for that process. I mean, the mappings, the Sparkle queries, and all those other things that will be needed, yeah. So I think that it's very good at the process of generating the ontology. I mean, it's several years. I mean, I have been involved on that for, I don't know, 6, 7 years or even more. I mean, from the original inception of that e-procurement ontology, and it's already a good basis. But now it needs to go a step forward into all the processes that will be needed by member states to generate the transformations, yeah, the mappings. I mean, I have been working with Spanish procurement data, and I know the goods and the bads, I mean, and how easy and difficult it is to transform some of those data sources. Mm-hmm.
And also, you have a very extensive corpus of data that you can use to, like the whole public tendering data history that you can use to apply the ontology.
There are interesting challenges over there, especially with the directive, the public contracting directive that appeared several years ago that made some relevant changes. And then, I mean, the older data is a little bit more difficult to handle. Yeah. There are some indicators that from the scoreboard, indicators that cannot be easily generated, yeah, because the data is not homogeneous, and then that would be a strong challenge.
But talking about, I would say, shifts and changes in data, would you see? I know that yesterday you mentioned that your team is not directly working on like using word embeddings to identify like semantic shifts, but still, like from a very generic perspective, would you see any, or in your own work you haven't really
we haven't really explored. I mean, things that we are exploring, obviously, as many others are doing, is in ontology engineering phases, how to use, I mean, generative AI for as a companion. Yeah, I mean, like we see those systems as a companion, as the domain expert, yeah, that can help you when you are doing elicitation, knowledge elicitation. And we are exploring that area as well as question answering, yeah, which is yet another, I mean, like of the typical cases that we have, but on top of the knowledge graphs, yeah. So just trying to see whether the knowledge graphs can help on the question answering phase, considering that, I mean, like the world of question answering has changed, yeah, quite a lot right now. So those are the two areas that we are exploring, yeah. Not generating automatically ontologies, but using these systems as a way to help. I mean, as a domain expert that can help you in the ontology development process.
Okay, perfect. Peter, last question. Peter, microphone. No, but then the thousands of people, exactly, the thousands of people online.
Some mic would have picked it up. Yeah, no. But you mentioned something about how beautiful would it be if I changed the ontology and then the shackle shapes would follow. But aren't these really separate things? Like, shouldn't shackle shapes always be separately managed from the ontology itself? Can you give an example of where that actually would?
They have different purposes. Yeah. Okay. I mean, and I don't believe on those ones who say that the shackle shapes are just the replacement. Shackle is the replacement for owl. I don't believe it. I don't buy it. Yeah. I mean, there are many people who are claiming that. I think that they are two complementary elements. Yeah. That you can maintain. In my opinion, they can be maintained separately. Yeah, because they have a different focus. Yeah. I mean, some of them are focusing on checking cardinality constraints. Okay. I mean, this is something that you do in shackle. You don't do it in owl. Yeah. Okay. Because they are focused on different things. Yeah. But then, I mean, they have to, I mean, when you are doing the maintenance, I mean, like ideally in the editors that you are using, they should be all together, and then, I mean, you could just manage all the changes together. Our experience is that in the end, I mean, shackle is just maintaining some files, text files, and then whenever you make a change on a property, then you have to go into that shackle shape and check the property, yeah? So, I mean, you know what I mean, that there is still manual effort because there is no tool support. Probably there is not much research to be done over there. There is only a little bit, yeah, that, I mean, could be considering differences on ontology diffs, yeah, and so on. And then, I mean, you could just react to those things. But in my opinion, yeah, they are different artifacts. They are complementary. They are using different parts of the processes, and they are useful for each of the parts. I mean, they are useful. I mean, they are very valid. But shackle, for instance, is not a replacement of owl, in my opinion.
Yeah, certainly not. And I was certainly not hinting in that direction, in the sense that also at SEMIC, we talk about, on the one hand, vocabularies, and we talk about application profiles on the other hand. One is vocabulary is expressed with OWL, RDFS, and so on. The other, SCOS, of course. Yeah. And then for application profiles, it's really about how do you validate the data itself, not the real world logic behind it. So that's for me a clear distinction in each case. So certainly not contesting that. Yeah, but I'm mainly concerned that automatically updating shackle shapes, I think that's really dangerous. Like if that would ever be in place, because you count on the fact that some data will come in a certain way, and even if your shackle shape doesn't follow anymore the real world semantics, I mean, it's more. I think it's worse that your application would stop working than that your application wouldn't follow the world semantics.
I see the point. Yeah, I think that it's mostly on the ontology engineering process and maintenance where this makes sense, but it's not necessarily automatic transformation of it. How many transformations do you do on an ontology that is already stable or mature? It's already on its 3.0 version. Yeah. Okay. You don't make any major changes. Basically, you may add a new domain, completely new domain. But you're not going to make major changes on the conceptual level. So there will be no major changes on the shackle shapes either. Yeah. Okay. So I think that it could be just alerting, flagging changes, and then just saying, oh, these are the things that you have to take care of. Yeah. Okay. probably this is my proposal. Take it or not.
Yeah, interesting. Yeah, I think there should be as well a knowledge graph about the domain models itself, indeed, that we can manage at SEMIC level, and then see all the updates. That would be a great idea.
Okay. So if there aren't any further questions, thank you a lot, Oscar. So I think the following speaker, hardly needs any. Who does not know Raf Beule? That's probably. Yeah. So Raf, everyone has already knows you. How to present you? I think you have been one of my biggest ping pong and sparring partners over the several SEMIC years. So thanks a lot for all of the wonderful work that you with your team and also Ziggy has performed. So I think you will guide us through some of the lessons that you learned over the years. So Raf, the floor is yours.
So thank you, Seth, for your kind introduction, and thank you for being the linking pin at SEMIC the past years. Now I would like to share our insights on modular decentralized algorithms called Oslo steps. Now imagine that I apply for a subsidy when renovating my home. Then for me as a user, the decision is taken based on data, but also based on an algorithm. And for me as an end user, it's not always, or in most cases, it's not transparent how the decision is taken. I know that in the beginning of the web, the founder of the web, Sir Tim Berners-Lee, had the idea to build in a browser an oh yeah button that you could say, oh yeah, why is this claim here? It would be stunning if we could have that with subsidies, that you see these steps are used to take the decision. And later on I will give an example on what could go wrong. Second of all, for the application owner. For instance, with a subsidy, the decision is taken based on legislation. When the legislation changes, often the application builder, who maintains the application at the level of a local, regional, or federal government, are not aware that the legislation has changed. And even if they know, they have a problem with evolvability, because rewiring your application comes at a cost when your rules are embedded and hard-coded very deeply into your application. Third of all, as a policymaker, I would like to find that the policy that we create, that it finds its way to the application in a decent and transparent way. In this presentation, we will use the example of Jan. Jan is 67. He has a disability and he's moving from Ghent to Antwerp. And he wants to renovate his home, change his home to lower some barriers for his disability. And what we see is that in the application that Jan is using, often the legislation is not from one governmental level. It comes from local legislations that may provide the subsidy, but also from regional and federal legislation that needs to decide what level of disability Jan should have to get the subsidy. But it's not even the rules that are decentralized, but even in one application, we often see that there are different copies of the rules for instance, a portal or for a chatbot. So a lot of challenges. The first step we took, probably all together the past years, was from centralized data to decentralized data. An initiative from more than a decade ago, the initiative of ISA Square, SEMIC, and different local initiatives. What we did there was implementing the once-only principle for data. Separating, for instance, if we have an application for grants with information of my home, my health, my identity, that we don't have separated silos of data in another application for building permits, again with information about my home, my identity. What we did was creating semantic agreements and separating the data from the applications. I think we could take a next step, separating the logic from the applications, because like in the past, and even sometimes nowadays, we have that data silos in the application. Well, we also have on the left-hand side algorithm silos, where even in our region, for instance, to decide whether you have a several level of handicap, whether you are a small and medium-sized company, that there are different rules in different policy domains. By creating more model algorithms, decentralized algorithms, we could reuse these pieces of algorithms, these parts of decisions, and reuse them in order to facilitate interoperability on the level of algorithms. So on the right-hand side, we see the also steps methodology, where we separate the logic from the applications. So, some time ago, Sir Tim, the founder of the web, came up with this slide. And there you see a kind of a path of evolution, starting with the XML schemes, where we had interoperability within one organization, moving to cross-organization interoperability, where we are using RDF and we can link data across data spaces. The next step is probably to move to inter-engine or inter-ecosystem interoperability, where we can also, have also interoperability on the level of logic. That's not only important when focusing on applications that contain logic, but also important in the context of data spaces. Because when we look at the definition of a data space, on the one hand, it's referring to rather technical interoperability on the level of data, but on the other hand, it's referring to policy interoperability. When I'm sharing as an agent my data to another system, to another agent, then it must contain logic traveling with the data that not only says something about access policies, but also on how this data can be reused. And there, model algorithms that are self-describing based on linked data could provide a solution. So in Belgium, together with the different regions, language areas, and our federal colleagues. The Internet Technology and Data Science Lab from Ghent University did stunning work implementing these principles. So on the one hand, working on a vocabulary that describes the way to make decentralized model algorithm, but on the other hand, implementing it. On the left hand, we have Jan, and Jan has information. It could come from Crossroad database. It could come from a personal data store. And in a second step, you have to reason on it, and there, the steps, the different parts of the algorithm are assembled as one algorithm. So they stay in the original sources at different governmental levels, and they are assembled. And then they can be used to reason on the data whether Jan is getting the subsidy or is not getting the subsidy, and there Jan can also say, oh yeah, why I'm not getting the subsidy, and then he could possibly see that in the step where they're checking his income, that it's based on taxes, which are lagging 1 year, and not on his actual income. And this process of different applying the different steps could be optimized, because often you have this is an old presentation, I think. It's an old presentation, but I will explain it. So you could have different parts going to take the decision. For instance, let me give another example. Applying for a passport. When I'm applying for a passport, it could be optimized in a regular procedure, but if my context is that I need it tomorrow, then I can pay more and get the passport get the passport faster. So in different scenarios, these steps could be optimized, and it could be contextual, but it could be also based on artificial intelligence that learns from previous processes that were executed by different citizens or businesses. So I was missing some slides, but I tried to still to explain it. So first of all, you have some criteria. So the criteria from Jan to have low income, be over 65, being a citizen of Ghent. Those criteria are very important in the methodology. Also the action of requesting the subsidy, and also a third part which is about the weights. And I given an example just before with requesting a new passport, where the weight could be, it has to go faster, and then the impact could be the cost. So until now, we have experimented with this methodology. So on the left hand, we have the example where the logic is separated from the applications and decentralized. And also, it would be great for transparency to have like an algorithm register, which could be just a catalog pointing to the different algorithms, and in this way create more transparency about the algorithms that are used. So what we learned is, first of all, to create applications where algorithms are working for us as a citizen, and not the other way around. So the built-in transparency, but also the built-in evolvability. The point that if your logic is separated from your applications and your applications change, that they could adapt very easily without the need of rewiring them. So today I would like to get some feedback on who is also working on algorithms and in a more modular and decentralized way. And also to explore whether we could make a proposal to SEMIC to work on share of and reuse of algorithms, where today SEMIC has done some stunning work about sharing and reusing of semantic assets, that we could do the same for algorithms, and maybe think on how a local and maybe European-wide registry of algorithms could look like. So if you would like to explore the work of the colleagues of Ghent University on the vocabulary to create those algorithms, and also the work on different regions, language areas, and our federal government on whether this works in practice, the whole process is published via this URL or by just following the QR codes. I would like to thank you for your attention, and I'm looking forward to your questions, remarks, and insights.
Thank you, Ralph. So it's a very interesting stone that you throw in the pond, the registry of algorithms. Any feedback on this?
Yeah, no, so it's very interesting. I think so I'm gonna check definitely the URL. I think the main problem is how much did you have a chance to apply it to some realistic data to search, for example, on this problem, and to challenge it against the realistic data, I guess. Because ultimately in our domain, so I'm from International Union of Railways, got lots of places where we have things that are specified or are following certain standards, and that we need to match against reality of another party, for example, the people running the train and the people having the infrastructure, and that goes all over the place. And listening to that, well, I would see applicability to this kind of algorithm, especially if you standardize them. But so essentially, yeah, did you get a chance to run it against reasonably complex real-life use case, or?
Well, thank you for your question and remark. Well, yes, we use live data. We use the Federal Service Bus, so it's live data about citizens. But it's data that comes from authoritative sources, so like base registries that have a feedback loop, and they are already used in a lot of processes. So the quality of the data is very good. And I don't think that the step of algorithms, it won't fix the quality of the data. It will focus on the quality and flexibility of the algorithms. So I cannot translate it to your context, but so you're working on ERA, European Railway Infrastructure? No, or in another context?
No, I'm not working for ERA. I'm from International Union of Railways, but ultimately we have relations between the data sets. But I think your point about quality of data is indeed the...
Yes. So for instance, if you have data about route compatibility for the trains, then if the data is of a decent quality, and I saw some good examples on queries, Sparkle queries, to check the route compatibility. Now I think some of the logic is in the queries and is in the application on top of it. It's that part that could be changed to this type of algorithms.
You mean the rules that we define what is compatible with not? No, that's
yes.
a rule, whatever. No, I was thinking about the land registry. I don't know if you handle this part, land registry data, that perhaps it might be what happened when the land registry data set define different classes compared to the ones that they are used in the railway infrastructure. And you need, I think that the definition of the tunnel is different. That's what you meant, right?
We do need to.
Yeah.
I'm just looking at it.
No, I think ultimately, so quality of data, definitely. I think if there are practical examples we can try to look at, then I think we got what we need to see how to move forward. Yeah. Thanks.
Okay, looking forward, and thank you for your question.
Thanks a lot, Raf. I'm just looking at the time and very happy now to present Peter Gabor, who represents the City Council of the city of Budapest. So Peter gave an excellent presentation last year at SEMIC 2022 in Brussels. The reason why we invited him today to do an update, because there's an absolute match on this topic of how, let's say, a traditional relational database can be augmented with AI. Peter, glad to have you.
Okay. Hello, everyone. I'm really grateful to SEMIC to have the opportunity to present our case study at this year conference as well. This will be another case study. It will be a case study Budapest City Council developed in partnership with Greenhill information technology company. But I think right now it would be good to have some exercise. So I would like to go interactive with you. Could you, those whose cities or settlements have trees in their area, raise their hand? Good. Keep it up. Don't put it down. Right. I'm happy to see lots of hands. I think this is very important. But how many of these hands have the knowledge that their municipality has a database on their trees in their areas? There are still some hands. Lots of hands fallen down, right? Those hands who are still up in the air, how many of you know that their database of the trees is available and open for the public? Okay, that's okay. So the result that there are, not all of you know about that there are databases on the trees in your area of residence. But I was very pleased to see that those who have database, they know that this is also available for the public. This first picture is supposed to be really dramatic, so get shocked. But without the lack of current and comparable and interoperable database of tree cadasters within Europe, has risks. It has the risk of poor management. It has the risk of lost opportunities in cooperation and in adaptation to the climate change. And I would like to refer to the issue of climate change with emphasis. Because of the climate change, the vegetation of our urban areas is also changing. The tree assortment that we are used before, or which were native in the areas, is shifting. Those trees who were native and were able to cope with the traditional climate in urban environment are becoming less and less able to adapt. So there is a change. It would be really valuable for cities and urban municipalities to have information about how the trees are performing, both in their vicinity, in their areas, but also what's happening into cities in other locations. So the technology is available. Using laser scanning, it's possible to scan in any objects, including trees. And in our research project, we found out with our partner that using this laser scanning, it's possible to to measure the metric database of the trees, like height, width, and how many leaves they have. But it's also possible to calculate their economical, ecological aspects of the trees, like what is the value of the trees, how much water does it absorb, how much carbon dioxide does it absorb during its lifetime. Using laser scanning, we basically produce a digital twin of the tree, and then this data can compared over time or compared with other trees of the city. Artificial intelligence is as intelligent as we are, as intelligent as we can train it to. So the Green Hill Company run this project with 5 partner cities, including Budapest, but also including Berlin, Lille, Paris, and Milan. And this is how this intelligence was trained to recognize the types of trees and separate different species in European climate. This is a quick snapshot of the pilot project, of our product. This is what we have achieved. I'm not going to present it for you, but if you're interested, how does it look? What is it good for? I'm really happy to share this information with you after the conference. Believe it or not, other people are thinking about using artificial intelligence for tree cadasters, not only in Europe. So the whole process, to my knowledge, started in Singapore, where they started using artificial intelligence and laser scanning to create tree cadasters. They already have their cadaster in operation. In Malaysian government has recently decided to sponsor 155 local authorities to create their artificial intelligence-based tree cadaster. In Australia, they developed an industrial standard. What kind of database? What should be the structure of such a database? And even in the poor US, they managed to provide a £1 billion fund to create such a research program and sponsor municipalities to create their cadasters. So we are not ahead in Europe, but we are also not behind. In this project, following the 5 pilot cities, at the moment there are 43 European cities who are piloting and try to use artificial intelligence and create their tree cadasters. As you see on the map, in Spain there is no project of this issue to my knowledge. But we have knowledge to share, and we are happy to share this knowledge with you as well. After creating the database, the following step would be how these databases can communicate with each other. So it would be really important to start talking about the database standard, what should be included, how can we calculate the ecological benefits of the tree, how can we calculate its economical value. And it also would be really important to agree how the monitoring should be used, how regularly and in what methods can we upgrade these cadasters. So I put my message at the end, not at the beginning. But my message is that it is the time now to run a pilot project, not on the technology, not only on the technology, but how run a pilot project on the databases and the database standards and structures in order to make them interoperable. Then we might start a conversation whether how should we use this data, whether this data should be standardized or should be centralized or decentralized. There are many issues. I believe the SEMIC and the expertise you have in other projects can be a valuable experience for us. So we are really hoping that we can move together in order to make urban tree cadasters interoperable. Thank you very much.
Thanks a lot, Peter. Alberto.
Okay, pretty interesting, definitely. I guess that you have mentioned that you have a database structure, do you have some kind of documentation or technical definition of the structure? So is it available and with what license?
Yeah, the Green Hill, the partner company, it is their product. So the database using the model developed in Asia, in Singapore, they adopted it to European climate, and they created this this database. At the moment, they are managing.
Yeah, but the license, is it open license or no?
No, no. No, and the other issue I haven't mentioned, that at the city we also have a publicly a database which was created in a traditional method and which is accessible for the public. And our pilot project was also about how our publicly available database can, how the database provided by artificial intelligence can be brought in and integrated into our publicly accessible database. Another issue I believe will be that luckily the trees, they don't subject of the GDPR requirements, so the data you gather from trees, it can be shared. But because of management reasons, many urban managing companies are not willing to share all, like industry companies, because then it will turn out that actually your the 50% of the trees in your city, they are really, they could be dangerous in case of storm. So there might be some consequences, financial or environmental consequences. But I think there should be a discussion about what kind of information should be shared and open and publicly accessible.
Oh, excellent, Peter.
To be honest, it looks very weird to me, because if you have to integrate this database of trees for water consumption or just management of the trees, you somehow need permission of the provider. So that's a locking definition, vendor locking definition.
There's we need an agreement. I agree.
And also, I think it's an absolutely brilliant project, perhaps to be upscaled at an EU level with other member states, and I think it's really something which would fit very well in the let's say the SEMIC agenda. Okay, brilliant. Thanks a lot, Peter. So our last speaker, Alberto Abea from Fireware. Many of you will know him, as he's the man behind the smart data models, also an important player for the Data Spaces Support Center. So I'm absolutely thrilled to learn more about your process and your insights on what you learned over the years.
Yeah. Thank you very much. I guess that my presentation will be slightly different. This is the title, Semantics for AI, the role of traditional semantics in AI. The question is it really important? My point is that it is, but it should be much more, much more. And is it possible to do it with the current approach? Maybe not. So if I have to put my money, I would say no. So I wouldn't put my money. So let me explain why. This is the point. So the first question that I want to make is that my general doubt, what is the role? Will knowledge graphs will help on AI? The short answer, yes. But is there enough semantic data for AI? We'll see. And then if standardized semantics will meet AI market needs, we make a kind of comparison. And then I will introduce 2 points. One is the concept of agile standardization, but not only the concept, but a running initiative, which is the smart data models. So first point, okay. Good. What will be the role of traditional semantics? My take, definitely. Knowledge graphs will help on AI for sure. So based on the existing taxonomies, ontology, semantics, I have a question, and I've seen some examples saying, oh, could we generate ontologies, taxonomies based on AI? I have guessed that likely. But to be honest, I'd like also to see it working, which is not the same. So is it possible? Yeah. But working and providing, let's say, reasonable results, I have not that information. Maybe any of you could share with me. That's the point. And also, data for training AI models remains necessary. If this data has a semantic content, very good. What if not? Let me put you in context. I have also another hat beyond my role at the Firewall Foundation. I'm also a researcher on open data. And since 2017, I've been running some research on the current status of open data just in Spain. That's the scope that we can get. What you see here is that we manually sample every open data portal in Spain. Manually, I insist manually. Connecting, checking, this, quite tiring activity. And these are the results. How much of the information released by the open data portals, the information are inside the public entities, municipalities, regional governments, and so on, and releasing to the public? How much of this information has a data model? Having a data model, only 15 plus 2%, 17% in 2021. The next report will be will be presented possibly this November. Okay, has not changed much. But in this 17%, only 2% has, let's say, a national or regional data model well documented. And in these 2%, inside these 2% are the semantic ones. Possibly, my estimation, because I don't have precise data, is possibly below 1%. What does it mean? It means if you are willing to train with data these AI systems, possibly the available information with semantic content is below 1% of the overall. If the open data information is the one that you choose for training these AI models. To be honest, I don't know where the AI trained models are getting the information from, but I guess that the open data portals are a good source. So basically, that semantically defined information is an exception. It's not the rule. I know that we are in a linked data environment and we are very proud of the semantics. That's good. And I guess that is the right way. But I guess if we just keep on doing the same things, we've got a problem. Okay, and now another point. Will semantics be capable to deal with AI market needs? Let me tell you, and I'm very happy because Raf commented yesterday that the usual time for creating kind of a new semantics, instead of being 24 to 30 months, as I pointed out, there is around 12 months, okay? Or even for a review is something like 3-6 months, okay. What happens with ChatGPT in the last 10 months? They got 180 million users. Sorry, this is only till August. So my question is, if you are a provider of an AI service, are you going to wait for a semantic definition before launching your project? I don't think so. I wouldn't do it. Okay? So unless we do something to provide quicker versions, I don't want to mean perfect, but quicker versions of the semantics, we've got a problem. Because possibly AI, which will enjoy every semantic information, will say, if there is no semantic information, I have to take something else. And they will take, sorry. So, are we doomed? No, no. The answer, I guess, there are solutions, and this is what I want to share with you. So first, I want to share some of the agile standardization principles. And I'm very glad because I agree with Oscar that the last point, that sustainability is key, sustainability. So if you are doing any kind of semantics, you need something which is not a project, has to be maintained. Maintaining the semantics is key. And the other thing that I want to share with you is not just to create semantics or standardize, you have to do it in the right time. If you have a need now, and you take 15 months to create a standardization, okay, I have to keep on working. I've been in the standardization in Spain of open data sets in 2000. We started in 2017. We finished in 2019, and we get 40 data sets standardized. What will happen with the other 700 types across the open data portals? Nothing. And even with that, with these 40 standardized, then you need to adopt it. And now in 2023, after 4 years of this standardization, it's not generally implemented. So unless you do it in the right time, don't do it. The second point is do not reinvent the wheel, which is very basic. Don't waste resources on something which is already done. As long, let me jump to the fourth, to be open. And that's why I'm very sad that you are not releasing the tree, because I guess that is a very good candidate for being a semantic at the smart data models with the definition of what is a tree, and to share across many, many domains. The third point is even more important. The point that we have now is that for creating a semantics, usually, we have a consensus procedure. A consensus procedure is just a series of meetings between experts to create kind of a specification, and takes usually months. Okay, that's good. I don't want to mean that this is bad, but this is not enough for the current market. You need to, and this is what we provide, is following the pioneers, as long as the pioneers share their knowledge. So imagine that you are the first in Europe creating a database of trees. I want to share this database and share with others that they can extend or modify slightly this initial database. So as long as you do it with an open license, you can do it. The next point, don't be overly specific. Of course, the first time that you do something, I have to emphasize, real use cases, not desktop work. Real use cases, you have systems with this data model working, not just definition. Why is that? Because every expert running something, when they put into practice, they realize, oh, this is not necessary, but I need this. We have this already filtered, and we only accept real use cases. Don't be overly specific. Let me put you an example. We were accepting a farm data model, and this farm data model has an attribute for three silos, silo 1, silo 2, silo 3. And we make this very simple question. What if we have 4 or 10 silos? What will we do? Okay, instead of 1, 2, or 3, have any array of silos, these kind of things. And the last point is flat, not deep. So in real scenarios, although hierarchy between data models and inheritance is very good, this is not that used. And whenever possible, make it simple. Make it simple and extend it later if you really need it, which not always is the case. So what we do is just, generates is not the right word. We just create, because we do not invent any data model. We just accept use cases, document it, and do these things. Let me check. Okay. What we provide is just the data structure. So what is the data model of a tree? What are the attributes defined in a tree, the height, the species, the water consumption, the CO2 production, whatever. We define what information, if this height is a number, if it's a text, if it's an object with sub-attributes or whatever, and a written description. Of course, everything open license, so you can reuse for any purpose, you can modify, and you can share the modifications. The single source of truth is JSON schema. Okay, is this JSON schema as powerful RDF or other semantic sources? Possibly no, but it's good enough. And it's very quick. And there is plenty of technology for dealing with JSON schema. So we don't have to invent anything because there are libraries across there. And with some Python scripts that we have defined by ourselves, but we are releasing, we automatically generate the specifications in 7 languages. Spanish, Italian, French, Japanese, Chinese, and German, beyond the source, which is in English. And we create also a database of attributes. You can download all the attributes of all of our data models, around 150,000. You can download in one shot, and there is always a link. And even more important, especially for semantics, let me share with you one experience. There is a I4Trust project. It was a project for creating tiny data spaces between 6, 7 participants. How much of the information in these 30 use cases will be with semantic context? How much do you think? None. I don't have any news that any will be semantically defined. That's reality. Okay? So, but this is, on the other hand, this is an opportunity, because what we are doing is that for every data model that we have, we are providing a linked data URI. And you can say, oh, but there are ontologies which are already defined. Very good. In that case, we have a mapping service. So instead of using these automatically generated URIs, which has content and there is no problem, you can map it with the original ones, or Raf, with Oslo. Oslo is already mapped here. And we keep the original URIs because they are the original URIs and you're willing to use it, why not? Okay? And the last point that we are doing is just creating a Python package. By Smart Data Models, you can download, and all the information, these 150,000 attributes, this database is inside. You don't need to update the Python package. There is a function that grabs the information from the original repositories, so you have always the information. Okay, and these are some services that we have for the users. Sorry to say, our contributors are very good at their, let's say, their area. They are experts, but they have not much knowledge about data modeling, not much. So we have to make the things simpler. Even we have, let's say, the simpler approach, which is a spreadsheet. You say, oh, spreadsheet, how can you define? Yeah, for the first approach, is good enough for the first approach. I don't want to mean that this is the final. And with this spreadsheet, we generate a JSON schema. Okay? We have other services for exporting. RDF will be very soon, in CSV, in YAML, in SQL, in DTDL, and so on. We have other services for an incubator repository. So you can work on GitHub with us, and I'm creating the data model of a tree. In fact, there is one candidate, but they haven't finished. So they can work there, and as long, oh, it's ready. We review it, and we approve it, or we make comments, and they have to change it. We can have another service, which is you have a payload, an example of your database, you put into this service, and they return you a draft of a JSON schema compiled with this payload. You can do it with CSV, you can do it with JSON, okay? There is also a service for browsing all the examples in all of our data models. You can check it out, okay? We have also, in the case that you need several contexts in different subjects, imagine that you have a project with a building, with a device, with another type of sensors. Okay, we merge the context of buildings, devices, and other sensors all together for your application. And the last point is that, minor thing, we provide a thanks and attestation of your contributions. Everything that we do is open license, so we provide you thanks. We are not paying you, we don't have that resources, but we can say you thanks, and you are officially defined as a contributor. And these are, let me check the next one, and these are the channels for supporting you as much as we can. Because the important point is to get in contact with the actual users, with the actual contributors. And maybe if these are not enough, maybe we'll have new ones. Okay? And let me just check, because there were some ideas that I don't want to comment. Oh, I didn't say, and it's very important. The Smart Data Models is not only a 5-word initiative, it's an initiative with OASC, Open and Agile Smart Cities, with one agency of the government of India, and with TM Forum, which is possibly the largest telco operators and companies in the world. I've commented that, yeah, and there is more than 100 companies contributing in these data models. Remember, We at the Smart Data Models have no specific knowledge on any of the 1,000 data models. We are not experts at that. We just curate, make it everything available, and very important, it's very easy to extend the data model. So how long does it take to create a data model if we have the example of the definitions? Basically, 1 day. 1 day. What do you need for extending this data model with an attribute? Basically 1 day. In 1 day, you can have a new version with, with the database updated, with the specifications in the 7 languages updated, with the add context updated, and everything updated. Why? Because everything is automated. We don't have resources for doing anything manual. Everything is done automatically. And last point is that this is not currently available. We have an export of the full database of smart data models in DCAT AP. It's been testing this week. And hopefully next week will be ready, not only as an export, but also for the integration into the data models block of data spaces. That's the goal. And I guess that's enough. I don't know how I'm on time. So thank you very much, and enjoy the smart data models if you wish. Thank you.
Thank you, Alberto. Any questions from the audience on the Smart Data Models Initiative or any other?
Yeah, I have one, by the way. Just whatever comes to my mind first. Trees. How do you convince a company, a business company, to share their data models, which they try to sell on the market?
Very good question. If you want, imagine that you're a pioneer in a market. What do you prefer, to have your own proprietary data model that nobody knows, or to be the pioneer and make others to be compatible with you? If you're a big player, I don't think that you are going to share your data model. So somebody, I guess, I'm a big player like Microsoft or this kind of thing. Oh, I've already forgot to mention something. Who is adopting these data models? Microsoft has taken some of these data models, especially those for smart cities, for creating their own classes of DTDL, which is a digital twins solution. Amazon is taking for the smart territory framework. Atos is taking the data models for the smart urban platform. The government of India is adopting formally for the interchange of data between cities. And some others are adopting as well. So we don't convince anybody. So we tell, if you want to be a pioneer and demonstrate that you are a leader, because once you are here, there is also a file which is the adopters. You can disclose, oh, this data model is being used here. It's been in the city of Budapest. And you are there, and potentially people will contact you regarding this data model. And of course, every contributor has an official list. You can disclose the information that you wish, your email or no, your project, your name, whatever. So it's not mandatory, but you get some dissemination because our role is to make these data models popular.
Okay. Perfect, thank you. Well, I would like to thank you all for this session, and I kindly invite you to go for a coffee, which will probably be again served in the big space on the 4th floor. And after that, we will have a very exciting closing high-level panel with, I think also, and then at the very end, the Vice Prime Minister of Spain joining us. So take a coffee and then head back to the main room. Thank you.